Okay, good morning. I'm going to go ahead and do a little bit of a review of last time just to make sure we got a handle on things. And then I'm going to talk about what we talked about in class today. So take a look at this example. This is an experiment. So what we have here, excuse me, is there's chronic tension type headaches. They occur daily for at least 6 months. Can antidepressant medications or stress management training reduce the number of and severity of these headaches? So if we look about it, what we have is we have some volunteers here. We have what, 1, 2, 3, I get 6, 1, 2, 6. We got 36 people. Got 36 people here. So these people down here, these are my subjects. They're my experimental units. So again, just as a reminder, the people who are going to be in this are my subjects because they're people, but in general, they're called the experimental units. Okay, now let's talk about factors. There are factors here. The factors are antidepressant medication, stress management. Those are my factors. Okay, those are my factors. Factors, I haven't said what exactly they do, but those are my factors right down here. Sorry, right there. The treatments are how you apply the factors. So in this case, we have some treatments. We have 4 treatments: antidepressant alone, placebo alone, antidepressant plus stress management, placebo plus stress management. So what that means is I have 4 different things that I'm applying to my subjects. Those are my treatments. So again, those are my treatments, as it says right there. So what we have here is we have our 36 people. Now what we want to do is outline the design of this experiment. What we're going to do is we're going to take those 36 subjects, and we're going to use some random process. We're going to use some random process to assign them to the treatment groups. So if you think about it, what we're going to do is we're going to go ahead and let's say we're going to, flip a coin, or not flip a coin, flip a coin with that. Something that has 4 outcomes. Something that would have 4 outcomes. Okay, what we're going to do is we're going to roll 6-sided die. And what we'll do is we'll ignore outcomes 5 and 6. So number 5 and 6 won't count. We'll roll 1, 2, 3, or 4. So what we're going to do is we're going to use some random process. We're going to randomly assign. And we're going to randomly assign to each of the 4 treatment groups. So again, what we'll have is we'll have antidepressants only. We'll have placebo only. We'll have antidepressants and stress management. We'll have placebo and stress management. And ideally, what we'll try and do is we'll try and make the groups as equal as possible. So realistically, what I want to do is I'm going to put 9 people in here, 9 people in here, 9 people in here, 9 people in here. And what I'm going to do then is I'm going to watch them. I'm going to let them go through the process of, doing this, where what they're going to do is they're going to tell me how many headaches they have. So what's going to happen is I'm going to monitor these people. And what I'm going to do here at the very end is I am going to, what I'll do is on all these is I'm going to monitor the number of headaches. Monitor the number of headaches. I'm going to do the monitor here. I'm going to do the monitor here. Okay, so now what's going to happen is at the end, I'm going to make a comparison. I'm going to compare the 4 results, and I'm going to see what happens. So in this case, this is called a randomized comparative experiment, or comparative randomized experiment. That's randomized comparative experiment. Again, because what I did is I did something random to assign those 36 subjects. I monitored them, I compared them at the end. So that is a randomized comparative experiment. Now, what I would do is, if I wanted to figure out how I would randomly do that, this is what we did on the quiz. I'd somehow assign numbers to these people, or I'd do the big hat method. I'd put all 36 of these names in a hat, and I'd reach in and I'd pull out 9 names. I mean, there's lots of ways to random. The way that you could do it according to the book is you would number these guys 01, 02, 03, 04, 05, 06, all the way up to 36. And then what I would do is I'd use a random number table, and I'd pick 4 groups of 9. So that's my randomized experiment. That's my randomized experiment. Now, we also talked about something called the block experiment. What a block is if I know something about these people ahead of time that might influence the results, I'm going to block. So let's say, for example, of these 36 people, I know that this half right here, the half over here, these people had it really severe, and these people have a mild case. So I have severe 18, mild 18. What a block design would be is I would block people by severe and mild. And then what I would do is I'd have those 4 groups randomly assigned out of this. So it'd be the antidepressant, the placebo, the antidepressant and the stress management, the placebo and the stress management, and I do the same thing over here. I'd have the 4 for the mild: antidepressant, placebo, so antidepressant, placebo, antidepressant, and stress management, placebo, and stress management. And again, in this case, there'd be 18 for severe, 18 for mild, and somehow I try and make those groups as equal as possible. So, it might be something along the lines of, 4, 5, 4, 5, 5, 4, 5, 4. So it adds up to 18. But the numbers are roughly equivalent. And again, I would do a random process. There would have to be some randomness to this, names in a hat, whatever it would be. Then what I'm going to do is I'm going to do my monitoring again. So again, I would do my monitoring. But at the end, I would compare within the severe sufferers. So again, do my monitoring. I do compare within mild sufferers. And then at the end, I compare between them. So that's a block design. So it's just a little bit of a review of what we did before. Let's talk about another one of the examples. So again, let me just look at this problem. We're going to talk about this beginning of class. It's a little bit of a review, so it'll be kind of a repeat if you've already been in class. As men age, the testosterone levels gradually decrease. This might cause a reduction in lean body mass, an increase in fat, and other undesirable changes. Do testosterone supplements reverse some of these effects? A study in the Netherlands assigned 237 men aged 60 to 80 with low or low normal testosterone levels to either a testosterone supplement or a placebo. The report in the Journal of American Medical Association described the study as double-blind, randomized, placebo-controlled. What does that mean? Well, again, double-blind means that the people, these 237 people, didn't know what they got, nor did the researchers doing the study itself. There was someone up on high who knew, but the people directly involved in the study had no idea. So that's what double-blind is. Randomized means that these 237 men were randomly assigned to 2 different groups. Like there was then the hat, the big hat method, or some other method. And placebo-controlled, again, means that half the group received the testosterone supplement, half the group received, like, a sugar pill, a placebo. Again, this is for the placebo effect, so that people don't respond thinking that they're getting better just because they're taking the pill. So that's the idea of a double-blind randomized placebo-control. Hopefully that helped a little bit. I'm going to go ahead and talk about what we did today. And what we did today really were 2 things. First thing was called statistically significant, and hopefully the activity gave you some idea of statistically significant. The other thing is, this is our thing. It's called scope of inference. This thing right here is called scope of inference. And what you need to be able to do a lot on the AP test is you need to understand, when you look at a research study, what kind of things can you conclude? So there are 2 types of conclusions you can make. There's inference about the population. There's inference on cause and effect. Easiest way to say it is inference on population. That's basically saying people who are similar to this group had this result. Therefore, people in that group. So like, let's say I had men 18 to 34, and I randomly selected 50 men 18 to 34. If I made an inference on population, I would say that because it happened similar for these men 18 to 34, I would expect similar results in other men 18 to 34. That's an observational study. That's usually what we do in an observational study. Inference on cause and effect, that's our experiment. That's where I believe that because I did that randomized trial with the placebo and the antidepressant, I'm going to try and draw a conclusion that says, hey, the people I gave the antidepressant and stress management to showed the greatest reduction in headaches. So therefore, I can draw a cause effect. I can say that I believe that the stress management and antidepressant actually led to the effect of a reduction in headaches. What you need to do is you need to look for some phrases: randomly selected, randomly assigned. So if something was randomly selected, typically we're talking about an observation study. So this one says if someone was randomly selected and they were randomly assigned, it kind of fits both. I will tell you, this is a very, very rare occasion. This doesn't happen often where we randomly choose people, select people, and then randomly assign them to a treatment. This would be the ideal, but again, it doesn't happen that often. I would say this is a very rare occurrence. It's the ideal. It's like the premium thing. Over here, where we randomly select, but we don't randomly assign, this is where we're talking about for my observational study. If I don't randomly select them, but I do randomly assign them, this is going to be where my experiments fall. And then down here in the bottom corner, if I neither randomly select nor randomly assign, this is junk. This is garbage, honestly. This is no good. Basically, what it means is it's a useless study. The only conclusions I can draw are on the people who participated. I can say the people that I worked with had this result, period. Doesn't help me. I can't make conclusions and move on from that. So observational study is where we can make inferences about the population. Hey, the people I selected this from had these results. Therefore, I can draw a conclusion that people from this population I selected from tend to show these sort of results. That's an inference about population. It's not saying that whatever I saw was cause effect. It's just that people who seem to fit in this group also seem to have these results. Experiment is where I do a cause effect. This is where I impose a treatment. This is when I randomly assign and running an experiment. And this is where what I would say is that I can say that I believe that this treatment that I imposed led to this result for this group. Therefore, I'm going to generalize it to the entire population. So that's scope of inference. So for example, if we looked at an example here, so a small-time dentist wants to know if a daily dose of 500 milligrams of vitamin C will result in fewer canker sores in the mouth than taking no vitamin C. They're going to do 4 studies. Design 1, get all dental patients in the town with appointments in the next 2 weeks to take part in the study. Give each patient a survey with 2 questions. Do you take at least 500 milligrams of vitamin C a day? Do you frequently have canker sores? Question 1, based on the patient's answers to question 1, divide them into 2 groups, those who take at least 500 and those who don't. This is an observational study. In this case, what we're going to do is this one, I'll be honest with you, it's not necessarily great at all because you didn't really randomly select anyone, and you definitely didn't randomly assign anyone. This is that bottom right corner. This is not anything. This is not good. You basically could draw conclusions on just those people. Design 2, get all dental patients in town with appointments in the next 2 weeks to take part in a study, randomly assign half of them to take 500 milligrams of vitamin C each day, and the other half to abstain. For 3 months, measure the canker source. This is an experiment. So what this would be, first one was here in the bottom right corner. This one's here, down here, running an experiment. Design 3, select a random sample of dental patients in town and get them to take part in a study. Divide the patients into 2 groups as in design 1. So I selected a random sample and I want to go ahead, but I'm not imposing any treatment. This is kind of our observational study. Design 4, select a random sample of dental patients in town and get them to take part in the study. Randomly assign half of them to take a 500 milligrams of vitamin C each day and the other half to abstain. Again, in that case, what we're talking about is we're talking about the ideal world. Again, it doesn't happen often. This is basically, I can make inferences on population and on cause and effect. So hopefully that helped a little bit. Again, a lot of the stuff we're going to talk about in class, so this might be repeat from things we did in class. So hopefully that helped.